Hi, Assalamualaikum warahmatullahi wabarakatuh. So, we are from Statistic for Engineering Technology Section 4 and we will be presenting our project. So, first of all, let me introduce our teams. So, I'm Muhammad Shazwan Izzat and the rest of our team are Jeevan, Dinesh, Afshin and Rohendran. So, let's move to the chapter 1, calculation of discrete random variables. So, the data that we use here is a factory in Penang has 30 employees. The age work in the factory is from 18 to 60 years old, while the monthly salary rate depends on the employee's age factor. So, I would like to highlight that the data that you see here is the data that only have age, average age, and also the frequency. So, let's move to the expected value. So the expected value is calculated by multiplying each of the possible outcomes by the likelihood each of outcome will occur and then summing all of those values. So this is the expected value formula. So the formula that you use here is summation of x multiplied with px. So the x that we use average age, and the px is the frequency. So we will get the 37.93. So let's move on to the variance. The variance of the discrete random variable is defined as the weighted average of the squared difference between each possible outcomes, and the average value of the outcome will the weights being the probabilities associated with each of the outcomes. So this is the formula of the variance. So there's two formula. First of all is the formula of variance itself, and the second one is the formula that we will get the ex power of 2. So ex power of 2 basically it's the same formula of the expected value, but just it will we will add the power of 2 at the beside x. So as you can see, we will get 1579.57, and we will enter that value into the formula of variance, and we will get the variance is 140. So let's move on to the standard deviation. For discrete random variable, the standard deviation is calculated by the summing of the product from the square of the difference between the value of the random variables and the expected value, and the associated probability of the value of the random variables taken over all of the values of the random variable, and finally taking the square root. So basically is this the square root of the variance. So as you can see here, the standard deviation is equal to variance power of 1 over 2, or equal to square root variance. So the square root the variance we will get just now is 140.989. Yes, right. So we will square root it and we will get the 11.87. So that is the standard deviation. Now we will see to the probability. So there are three cases in our data. So first of all is probability x is lower than 28. So the answer we will get to the answer by looking at the frequency. So the frequency that x is lower than 28 is the rate age that 18 until 27. So the frequency of it is 8 over 30. So let's move to the next cases. Is probability x is greater and equal to the 28. So for these cases you can use two methods. So the first method is by adding the remaining probability frequency that over 28. So there's 4 frequency right there. Is 6 over 30, 9 over 30, 5 over 30, and also 2 over 30. And when we will summation all of it, and we will get 22 over 30. So we will use another method which same question also. So P probability x is greater and equals to the 28. So the different method here we use is we will use the formula of 1 minus the probability x that lower than 28. So 1 minus with the 8 over 30 that we will get just now from the first cases, and we will get the same answer, which is 22 over 30. So that's all from me. I will pass the next chapter to my group mate.
Hi everyone, my name is Afshin, matrix number CN0251. So today I'll be sharing about binomial distribution. So what is binomial distribution? So as you can see, binomial distribution can be thought of as simply the probability of a success or failure outcome in an experiment or survey that is repeated multiple times. The binomial is a type of distribution that has two possible outcomes. The prefix "bi" means two or twice. For example, a coin toss has only two possible outcomes, heads or tails, and taking a test would have two possible outcomes, pass or fail.
Okay, for the calculation part, step 1 is we need to check whether it is the normal approximate can be used or not. So hereby P equals 0.32, Q equals to 0.68 and N equals to 100. Since NP equals to 32 and NQ equals to 68, the normal distribution can be used to approximate the binomial distribution. So step 2 will be find the mean and the standard deviation. Mean will be 32 and standard deviation will be 4.66. Step 3 will be we should write the problem in probability notation using x. Probability x less than 30. So step 4 will be rewrite the problem using the continuity correction factor and show the corresponding area under the distribution. Probability x less than 30 plus 0.5 equals probability x less than 30 0.5. So the fifth step will be find the corresponding z value. The z value is 30.5 minus 324.66 equals that will be negative 294.16. So the last part will be find the solution. The area of the left of z is negative 294.16 is 295. Hence, the probability is 295.20 or 2.95%. It can be concluded that the probability of a player getting at most 30 hits in 100 times at bet is 2.95 percentage. Thank you.
Hello everyone. So it's a very good day to Dr. Yuswana. My name is Jivan Analiki Sadasivam. My entry card number is CN210331. Today I'm going to present about a chapter in statistics, that is chapter 5, which is calculations of hypothesis testing. Actually, what is hypothesis testing? Hypothesis testing is a type of statistical analysis in which you put your assumptions about a population parameter to the test. It is used to estimate the relationship between two statistical variables. To do the calculation for this chapter, we need the data. So this is the data that we use. So basically, this data is the data that is used for max vertical jump before the training and max vertical jump after the training. Just a normal two sets of data which consists of 30 players. Using the data set of 30 students for the table, test the claim whether the players who improve more than 1 inch and above perform better gameplay than the players who did not improve, which is equal and below at the end of month using 0.05 level of significance. These are the result we're gonna get after we do it. So the solution, there are two types of solution in this, which is case A, player who improved more than 1 inch and above. Another one is case B, player who did not improve equal and below. Then I will continue with the calculation, that is case A. So the sample size n1 is equal to 20. Then the second one, we're gonna calculate sample mean. As we know, mean is the average of a data set found by adding all the numbers together and then dividing the sum of the numbers by the number of numbers. As you can see, we got the mean, that is 482 divided by 20, which is 24.1. The second one we need to find out is variance. As you all know, variance is a measure of dispersion that takes into account the spread of all data points in a data set. So as you all can see, the variance for this case A is 212.99 divided by 19, which is 11.21. Then final one is the standard derivation. As you all can know, standard derivation is the average amount of variability in your dataset. In this case A, our standard derivation is 11.21 to the power of 1 over 2, that is 3.35. So the next one will be continued by Dinesh.
Hi everyone, Dinesh here. So I'm going to explain about calculation case B, which is player who didn't improve equal and below. So sample size n2 equal to 10, which means 10 players. For sample mean, x2 equal to assumption x over n. X is the value of the after training and n is the total of players. So I get 23.6. And the variance as to power of 2 equal to assumption x minus x2 over power of 2 over n minus 1. So you get x is the after training result minus x2, which is you can get from the sample mean, and n is the total per year. Then you get 18.94. Standard derivation s2 equal to s2 power of 2 bracket power of 1 over 2. So I get 4.35. For calculation final, level for significance A equal to 0.05. Therefore, null hypothesis HO equal to x1 equal to x2. So alternative hypothesis H1 x1 more than x2. We use one-tailed distribution and z-test. From the table of the z-test, we know that when A is 0.05, z critical z star equal to 1.645. For to get z-test, a formula which is bracket x1 minus x2 bracket, and then minus u1 minus u2 bracket over s1 power of 2 over n1, and then plus s2 power of 2 over n2, and then power of 1 over 2. So total we get 0.32 is less than 1.645. So the value you can get from this table. Then the decision we take is the decision is fail to reject the null hypothesis. For conclusion, there is not enough evidence to support the claim that the players who improve more than 1 inch and above perform better gameplay compared to the players who did not improve, which is equal and below in the end of the month using significant level of 0.0.